Okay. Good afternoon. Hey, I'm so happy to see you at this session. Not going to the cool sessions. Come to the real interesting session is SQL. So I'm Lindsay Allen, and my co-presenter, Jason Schumack and Jakob Schmacek. I've been practiced last name. Oh. And we're here to actually show you in the past year, 2017, since 2016, and what new capabilities and investment we have put into SQL and shipped in Azure as well. So the key takeaways, I hope, want you to have or walk away from this session is to think SQL running in Azure PaaS, database and service, is your database on autopilot. It's better than this zero, no driver thing. It's your database on autopilot. So I want to set context stage a little bit, right? So SQL Server as product existed for 28 years. And we have one engineering team called the SQL engineering team. We built this product. We have different deployment environment, surface to you either as the box product or in the hybrid environment, like in VMs, either in hosters, in Azure VM, or in our competitors' cloud, or in our cloud, right? Public cloud in Azure runs as PaaS service or called the database and service. And at the core is exact same code. It's the same code and the same developer writing it. And we actually do deploy to the public cloud first, to Azure SQL Database first. So as we're speaking right now, in Azure SQL Database, running in public cloud is running SQL Server 2017 ++ code. Thank you. So the experience will be consistent, and I know we have different marketing names for different surface areas, different services. They all SQL. All you need to remember, it is SQL. It's the same thing. And in the past, we had a lot of challenges, and because when we lit up a surface area as a managed service, because we have to run it, right? I tend to tell my boss is now I'm like IT for everybody, right? I'm running our databases. I'm IT for everybody, but don't have a big team, right? Team is not big enough to run all these millions of databases. So we have to get smart. We have to automate. This new terminology called AI existed like for a very long time, right? You just basically get your machine to learn from the data and take some actions automatically, right? That's called active learning. When machine know how to learn, it's like a baby, right? When you learn how to do something from inputs, and it becomes intelligence. So we are very motivated to be the very intelligent cloud because our developers actually want to write new code, want to write new features, right? So if you look across our investment, and we break it down to like 4 pillars. Intelligent database and service, we invested in lots of automatic tuning, including automatic performance tuning, automatic cost optimization. Your high performance workload still actually need to be cost conscious, right? If you actually have a super fast running workload, cost half of your revenue, I don't think your CFO will be happy, right? So need to be fast and need to be cost conscious. And privacy and trust, that's the second pillar. Security is the most important thing these days. And because it's a competition, right? And you make your data secure, make your access secure, somebody break it, right? Then you actually have to learn and improve. So we invest a lot in security, data privacy, and smart security and privacy. And seamless and compatibility with the SQL Server. Because the last thing you want is build your application for SQL, then rebuild it for cloud. That's just too much work, right? And it's not sustainable. So we want to make it as easy as possible. Deploy it wherever you want, right? Depends on where your business leads you. Of course, there's cost. In the competitive TCO part, I know we talk about performance and cost, you can load up AWS price page and load up our page and compare the price, right? And everybody thinks they're cheaper. But instead of I go tell you this dollar amount, I'm going to show you the example of how our IT actually using our intelligent path save millions of dollars, make our CFO very happy. So last year, 2016, this is what we have in each pillar. And all the core engine features are there, right? There's Columnstore, In-Memory OLTP, and a very fast, efficient query engine, and both in SQL and in Azure. And as a matter of fact, I think Sunil and Kevin have a session tomorrow talking about a Columnstore In-Memory OLTP. And we have a predictable performance we shipped with a SQL Server 2016, allow you to actually froze a query plan in point in time, so it doesn't get affected by statistic change, right? And same thing along the privacy and the trust. And we have active monitoring engine, auditing, firewall, and all these features. I won't save time not listing it. And so in the past year, here's what we did. You see everything in yellow are new. They're in different states. Some is G8, a lot of them G8, a lot of them in public preview, and also there's a couple in something called a technical preview, because they require special technology, which is not completely released from hardware guys and our hardware guys, everything, right? But we're going to show you, because we have customer tried it out, we made an announcement, it's really cool. So I'm going to pause here to 2 seconds so you can read it. So I don't have to read it. I think you read faster than I pronounce them. So what we'll do in next rest of the session, we'll go through each of the pillar and talk about a few of the features, either in public preview, we think it really matters, and or is G8 already, and between Drazen and Jakub, we're going to actually demo how things works. And we're going to show you SQL agent actually work in SQL Azure SQL Database. Okay, we're going to start in the first pillar, the intelligent database as a service. And we added a lot of automatic tuning both index and the syntaxes and your query plans. Will automatically correct your plan. If we notice the plan, actually the new query plan is actually regressing to a certain percentage, 20 or 40%, and we'll stop that execution. We get you a new plan. You don't have to do anything. And this is in SQL 2017 as well. And we shipped Graph. Graph database is big deal these days, and in SQL 2017 and in Azure. And we added AI. I think most important thing, I know everybody talk about R and Python, everything, those are just language used for AI, right? The most important thing are the algorithms, right? The algorithm today is super tuned and more performance compared to 20 years ago. We used to, back in SQL Server 2000 times, we shipped this thing called data mining. I don't know if everybody remembers. Data mining turned into machine learning and turned into AI. The algorithm back in 15 years ago is not as smart compared to today. Even just look at the simple neural network, right? It's a lot smarter. So what we did actually is we give you our service. It's in SQL DB in public preview right now. And we added a native machine learning function. But this time around, we're able to actually update those functions easier. So in T-SQL, you get a new keyword now, predict. Predict actually going to call the native implemented Revolution Analytics predictive model functions. So you can train the models. I think in Rohan's session, I don't know how many of you went. You can train your model in any other language you want, right? And you can take the binary trained model and deploy in SQL Server and call it from predict directly from your application. So because it's a native function, it's available right now in every single SQL database, everywhere. So I'm getting into a few of these features to give you a quick overview. SQL Graph is generally available right now. And the reason we actually shipped the SQL Graph is because for all the modern applications, are customer-centric. In order to actually get more insight from these connected data, you don't know this information exists, right? You want to traverse through these connected graphs in your database to find new insight. Even simple things like, the car parts recall. Generally, if a Honda recalls something, they recall all the car in that year, right? They don't really know which car actually have defective parts, because parts get assembled in the cars, the car gets sent to the dealers, and dealer gets sold to someone, right? It's very hard to track it down. But if you have a graph, actually can easily do a matching, pattern matching, without having to join like 10 tables, 11 tables together and scan every single table, right? So that's the power of graph. And we integrated that with the SQL engine. We introduced new object, the nodes and the edge, and the new match syntax, leverage the power of in-memory database, Columnstore. So it can run really fast, very performant. We have Microsoft Dynamics CRM system using SQL Graph heavily. So give it a try. There's some really cool demos out there we put in the GitHub and in our blogs. You can build a recommendation system with Graph, just Graph, friends and friends, right? Another major thing generally available today is adaptive query processing. One most painful thing for DBA is upgrade your SQL Server, right? Between versions, something changes about the query optimizer. You might get a different plan. And actually, lots of time it's not because our query optimizer changed something. It's because your data distribution changed a bit, and we take that input and had different estimation, right? And because before, if you see the before picture, the workflow with query execution will start. We take statistics, we store it on the leaf nodes, and we run that through very complex optimization algorithms. And it's estimation, right? So we use the cardinality estimator and heuristics and input into the optimizer, which is really complex, and turns through certain steps, iteration. We decide this is the best query plan, there go execute, right? So it's fairly streamlined. And so guess what, if we guess something wrong, and or if there's a complex query, there's intermediate results, right? For example, MSTVFs, table valued functions, there's no data in there, there's no stats, right? So we have to guess something. And it's actually a very high probability that guess is wrong. So for a complex query, there's a high chance that something is not optimized. So in order to increase our chance of guessing accuracy, which you're going to continue to fail, right? There's a case you can't guess it right. So we changed the architecture, and we introduced interleaved execution. Basically, for complex queries, we're going to execute first. We're going to persist intermediate results in memory. Of course, we'll get the stats. We use the stats to further optimize the next step of query execution. So this way, we can be more efficient and generate the execution plan for large complex queries. And also, we introduce the further adaptive part. This is all machine learning thing, right? And we will base down your execution on this memory grant. Sometimes memory grant because we're a highly concurrent system. So we have a fixed sized memory grant per execution type, because there's not enough memory to go around if you have like 1,000 concurrent users, right? So the memory grant, we actually we're very economical on how much memory we grant per session. And in some cases, you don't have enough memory, what happens is spill into TempDB. When your execution results spill into TempDB, it slows everything down, right? So what we do now is we learn, it's a machine learning, right? We'll learn from execution pattern, we notice there's spill. Then we will adjust for next execution, and we stop spill. The demo, I don't have time to show it, but there's in YouTube everything. So now if there's a spill in TempDB, you just execute it one more time, it'll be gone. Yeah, we're actually learning as you're executing. Same thing with the join patterns. And if we get to the estimate, the rows act smaller than what actually is, so we'll opt for a nested loop, right? Sometimes it's too slow, and because there's lots of rows, and we'll adapt to a hash join. improve performance. Automatic tuning. And so in Azure, advantage is we collect a lot of telemetries, Even individual SQL servers have lots of telemetries as well. And the important thing is, in Azure now, we actually use this telemetry to do something for your workload. And we actually can automatically, one click, you can enable it. I think we turn it on by default. And we will actually automatically adjust your indexes. Either create new ones. Of course, we do estimate on cost of creating index and the impact, or delete the index not being used. And actually, it will mitigate a lot of issues before you've seen it, right? All of this are transparent to your application, of course. And so we can create missing indexes, we can drop unused ones, and of course, we can automatically correct or force the previous good plan. And, oh, that wasn't me. OK. And furthermore, generally, you don't have one database. How many of you are actually managing more than one database? I hope that's pretty much everybody. Good. So we got lots of feedback. One database at a time is no good, right? Because that's just, unless this is one database and mission critical, and it's the most important thing, you can afford a full-time DBA. Generally, a DBA, for SQL DBA especially, you're managing a lot of databases, right? And so you want to monitor, alert, and tune and root cause them as all at once, right? As a single glass of pane to look at these. So performance insight integrated with OMS allow you to manage thousands of databases as one. With that, and I'd like Dresden to actually show you how that actually works.
Thank you, Lindsay.
Thank you.
So I'm going to demo Intelligent Insights in a minute or so. But before we go there, let's take a step back and let's think a little bit more about this monitoring scenario. So hundreds or thousands of databases. You may have created them in the cloud. You may have migrated them from your on-premise systems. Now, you would want to monitor those, right? They are running some of your potentially most critical systems. You need to be aware of what's going on with all of those databases pretty much near real time. Well, as Lindsay said, we're collecting lots of telemetry from all of those databases. And what we're doing is we're actually funneling it into a single place in Operations Management Suite. You could have your own workspace where all this data about all of the metrics flows and ends up. And there, you can have a reporting experience on top through a graphical user interface that aggregates data and shows you some charts. Or you can do things like log search and so on and so on. This is also pluggable into your other systems, potentially through Event Hub or something like that. You can basically flow the data to somewhere else if you have a third-party solution of one of your own. So let me first show you how that looks. Let me go to a Azure SQL Analytics solution that we have created in OMS for all SQL databases recently over the last several months. And we'll start there. OK, so here I went to a demo VM, and I have OMS opened right here. And this is the Azure SQL Analytics style. So I'm going to click on that and enter my dashboard. Now, this dashboard is my starting point for SQL Analytics in OMS. And here I have an overview about what I'm monitoring here. So I have 2 subscriptions, 44 Elastic pools, and 1,650 databases. By the way, these are our real subscriptions from our dev team. So lots of these are our own dev and test systems. So this is not fake data. We're actually monitoring these systems through this workspace, right? And then on the right-hand side, I'm looking at some aggregate charts of errors, timeouts, DB weights, blockings, query weights, and so on. So basically, I can very easily drill down and look at some of these dimensions I'm interested in and explore more. So for example, let's click on errors. The moment I click here, it takes a little bit of time to load the data. But where it ends is presenting me with this dashboard where I can very easily, from the left-hand side to the right, filter on an entity I'm most interested in. right? And on the right-hand side, I have the top list of errors happening, right? So for the purpose of this demo, I will click on one of these servers. And now I have drilled into it. So I have all the databases on this server, and I have a list of errors happening on this particular server. And when I click on one of the errors, basically a window opens where I have drilled down into this error, and I see that it's a lock request timeout period that has exceeded. So that's the error text. And I'm also seeing the time series where it shows me how many times this error has appeared over a certain period of time. Now, this is your self-service experience. You can do this, and this is what clearly means that Azure is not a black box for you, right? Clearly, there's data, maybe even more that than you have today in your existing systems, right? And we will continue to improve this. We will continue to give you more transparency and more control so that you can feel good about running your databases in Azure. But that's not all. What Azure can do for you and what Azure SQL Database is doing for you is it can provide you even better experiences. By having our own expert systems developed in the background through which we funnel all this telemetry, the expert systems developed by our data scientists and engineers, we basically constantly monitor the same telemetry that flows in here. We look for patterns, and where the expert system thinks there are potential performance issues, it will create an alert, provide the alert to you, and do a root cause analysis and provide you that with the alert, so that it can get you really close to either mitigating the issue or fixing it. So let me show you how this looks. I'm back to the home dashboard. If this, okay, cool. So I'm again entering the dashboard, and now you will see that there is this tile here called Insights, and it shows me something. It shows me that there are 24 active intelligent insights happening all over my 2 subscriptions, right? And I can, of course, drill into it, and I get the same dashboard where I can apply filters as with errors, as we've just seen. So I will click on the same server, and on that server, I have these databases, and I have a certain number of insights here. And insights could be anything. Like there's like a 25 categories that this expert system is catching. It could be blockings, it could be hitting resource limits, it could be plan regressions, whatever. And when you choose one of these insights and drill into it, it will display you a screen like this one. It would say that a detection is in progress. It is still active. It will give you the time when it first appeared, the last update, and then when we think the issue was worse. And it will say the database is hitting its I/O limits. Average consumption has reached almost 90%, right? So it's giving you a hint as to what seems to be the problem. But not only that, it also gives you a query that's been impacted, and there's only one query impacted by this issue here. And it also gives you query text, gives you the number of executions for this query over time, and the duration in total, so that using all this data, you can really put 2 and 2 together, right? And you can decide maybe you're going to mitigate this issue very quickly by raising the I/O quota and maybe going for a slightly higher service tier. Then it's mitigated. And then you can actually take this query text, go back to your system, to your SQL instance, to your SQL Server database, and actually look at the query execution plan and try optimize it so it uses less I/O. So the choice is yours. SQL Database will make sure that it helps you come close to mitigating or fixing your performance issues with intelligent insights. This feature is in public preview starting this week. Back to you, Lindsay.
Thanks, Jonathan. Yeah, so imagine your CEO calls first thing in the morning, you know, why is my report yesterday didn't show up, right? Or was there an incident? You can open up OMS portal, you can answer that question right away. So let's move on to the security and privacy. We have a threat detection G8. And we're the only public service can automatically tell you the access anomaly and alert you if there's some potential SQL injection attack. And we also have AAD, Azure AD integration and multi-factor authentication. I had a long discussion about that with the customer just today. And bringing own keys with transparent data encryption. And the last three things we're going to show you. So security is like a multi-layer of defense, right? We have the most secure engine, and rated 7 years in a row, we're the least vulnerable. And we added all these layers of security to the SQL engine. And started with protecting your data by very advanced encryption. And we add cell-level control access for the data, both actually by filtering and blocking. If actually you don't have permission, you could actually get blocked, don't know the data is there, right? So not encouraging brute force attack. And we have very advanced activity monitoring through integrated OMS and security data center. And we have actually very comprehensive identity management through integrating with Azure AD and building security. So first thing we put in public preview, I want to tell you, is this called service endpoint. I was trying to get a marketing diagram, didn't get one, so sorry about the complex diagram there. And so today, SQL PaaS service is actually a shared multi-tenant service, right? So there is an internet access point for your actually application to connect to the endpoint through the firewall. And what the service endpoint is, they actually added a special echo to only application or the application want access from the subnet with that echo can actually connect. So for example, if you have a network, right, it's a subnet, and you echoed that subnet in the SQL Azure service registry, right? And only application within that subnet can actually connect through the firewall. And the application out in the public internet and not registered and cannot actually access. So only certain subnet can access. This actually increases a certain layer security. So you can, for your deployment of SQL Azure, only application in, for example, in your corporate network IP address can actually access that service. So make it an additional layer of security for your SQL Azure. And vulnerability assessment, I know I'm going to spend a very short amount of time. There's a session, run it. I'm going to talk about, actually Ron going to talk about it tomorrow and in extensive detail. How many of you heard about this GDPR or the compliance? Yeah, about half. It's actually become a mandate, right, to run your service, and with anybody from European Union uses it, and on top of all the compliance requirements you have to meet, right? So it's a lot of work and resource intensive to actually service all the auditing and activities across for all your compliance requirements. So vulnerability assessment will help you with that by automatically scanning the surface area based on certain policies and rules. In addition to compliance, you can set best practice, and we have default best practice for you to actually adopt to scan the surface area based on security, or you have your corporate security standard. You can use this vulnerability assessment tool to actually scan all access surface area, generate a report for you. It's in public preview as of now, so you can go try it out, and on both the SQL Server and in SQL Azure. And now this is a technical preview part. So we released a first release of homomorphic encryption capabilities with SQL Server 2016. What it does is we actually keep data encrypted on the server side, and we don't actually decrypt it during compute. And the encryption key is actually a master encryption key is only maintained on the server side. So the data stayed on the client side. So the data on the server side will remain encrypted, stored in flight. It's always encrypted for super sensitive data. And the complexity is in order for us to enable this compute, right, we have to implement certain operations. And we choose to implement the most straightforward one in SQL Server 2016 and in SQL Azure right now are the equality clause. So you basically can search, for example, social security number by matching that seek that particular row. So you don't have to return the whole blobs, right, if you encrypt everything as blobs. And of course, when people see the advantage of this usage pattern, they want to have more computation, like aggregation, right? But in order for us to implement all that, it's quite complex. So good thing is technology advances. And our CTO, Azure CTO, Mark Russinovich, just published the blog and had a recorded video as well, called Confidential Computing. Use SGX chips from Intel. And this is a software guard extensions on their processors and can create a secure enclave on the server side. So what it does is now we actually create the secure enclave per session. And that session will created only when you actually connect securely. And in that secure enclave, imagine there's nobody else in there. So you can actually do, you can decrypt your data and do complex computation. And with that, I want to hand over to Jakub to both demo some of these features and talk a little bit more in detail. There's a security session coming up as well. Oops. Okay.
Thank you, Lindsay. So I'm going to start with showing you how easy it is to use vulnerability assessment in Azure SQL Database portal. So you start with simply clicking at vulnerability assessment under your database settings, and that brings you to a simple UI, a simple blade, where you can do two things. You can kick off either a new scan, a new vulnerability assessment scan, or you can review the results of the previous scan, including failed security checks and the security checks that passed successfully. Failed checks is typically something that you want to start investigating first because these are the indications of potential security risks that you want to mitigate. So let's look at a few examples here. So, for example, this page tells us that SQL threat detection is not enabled for my database, right? It is strongly recommended that you enable SQL threat detection. As Lindsay said, this is a feature that automatically detects security vulnerabilities, security risk, threats, and anomalies in your database. So you want to have it enabled. Now, this page tells you all about the risks of not doing that, but also it gives you a very easy to follow instructions, steps to mitigate this particular issue, the potential lack of compliance with your organization's policy. So you can, in this case, you can simply click at this link, and that brings you, that's a shortcut to another page in the portal, where in 2 easy clicks, you can simply enable threat detection to ensure that now you're in compliance and this security check will pass on the next vulnerability scan. So let's close all this, and let me show you one more example. So here we are being told that we have too many users, too many principals in our database who are assigned to high privileged built-in fixed server role, DDL admin, right? So we might be not adhering to the least privilege access policy that we should be adhering to, right? So again, one option, if this is a true issue, if we investigate it and we confirm that we are in a potential compliance violation situation here, again, there are easy to follow instructions that allow us to mitigate this problem. Or, alternatively, perhaps we have a good business reason for these 2 users to have this high privilege role, right? And we don't want this rule to fail on each validation, on each scan, vulnerability assessment scan. So to do that, to make sure that doesn't happen, we can simply add this configuration setting to our baseline, right? So that this security check is successful on the next scan. So let me now rerun the scan. And now this will take a few seconds to complete, but once it completes, you will see that the rule that checks that SQL threat detection is enabled, and the one that checks the number of users with high privileged roles, these are now or should be passing. And we are in compliance as far as these two rules are concerned, right? So there is lots of complexity that is taken away from you under the covers, but on the surface it's quite intuitive and easy to use, as you've seen, all right? So now, let me switch to a completely different topic. So let me give you a sneak peek at what these cutting-edge secure enclave technologies bring to SQL and always encrypted. So I have a database that is hosted in an Azure VM that is equipped with Intel SGX hardware. So we're going to be using an Intel SGX enclave under the covers to accomplish what Lindsay described briefly on a previous slide. So in this database, I have some information about employees, and that includes some pretty sensitive data like social security numbers and salary figures. I really want to protect that information. I want to make sure that is protected even from high privilege and unauthorized users, such as DBAs or malware running in a machine hosting this instance. And in fact, I have already configured always encrypted for these two columns to make sure that these two columns are encrypted and protected. So SSN, salary, these columns are encrypted. As a result, when a high privileged user, such as DBA, who doesn't have access to the keys, when they run a query like this, all they can get for these columns is ciphertext, right? And the same would happen if I attach a debugger to the SQL Server instance and try to scan the memory of the SQL Server process. All I could get is ciphertext of SSN and salary, right? On the other hand, a web application that I have here, which is configured with always encrypted and is considered trusted and has been provided with access to the keys protecting that data, it can access all that information in plain text, right? The SQL client driver assigned this application transparently decrypts that information. So that's the functionality we had in 2016. Now, what is new and exciting is that now we can build applications that provide rich filtering capabilities. So here I have a filter on salary, right? So I can constrain the result that I view on this page by specifying a salary range or some digits in the social security number, right? All obvious and intuitive, but now let's double click and let's see what's going on under the hood. So on the right-hand side here, you see a SQL profiler, and you can see that whenever I use this UI, this application issues a query, right? So let's look at this query. So this query has a fairly rich filtering criteria in the where clause, right? So it has a like predicate that does pattern matching on the social security number column, right? We have the range comparison on the salary column, right? Remember, both these columns are encrypted, even in memory of the SQL Server process. Again, outside of the enclave, so I'm revealing a little bit of what I'm going to say next. So what is really happening under the covers here, when SQL Server is asked to process that query, it sends the values stored in the SSN column and the salary column, which are encrypted, right? It sends these values to an Intel SGX enclave, where this data can be safely decrypted, and where these predicates can be safely evaluated, right? And then the results are returned back to the untrusted portion of SQL Server, and then back to the client application. So there's lots of complexity under the hood, and also more functionality that I could demo, but I don't have time here. But As Lindsay mentioned, we have separate sessions on all these, both the security and other features, so please join us there. Thank you.
Enclave is like you have your security is like a safe haven behind enemy lines, right? You don't trust anything in public cloud, but you can trust this because you're the only session can access this piece of memory enclave on the server side. So move on to the third pillar, seamless and compatible. So to start with, we have 4 nines SLA guarantees, and we have geo-restore, right? What we add is active geo-replica. This is what actually similar to always on. And this will give you way to actually distribute your data, actually high performance, and to the edge of your deployment. We support a multi-AG, we have long-term data retention to 10 years. And last but not least, on the distributed application. Generally, your application will end up distributed in some form and fashion. Not necessarily all have exactly same copies of data, right? And you have piece of the data need to be synchronized. We do have this technology like Azure Data Sync, and we actually bring it back to public preview and allow you to distribute the data. And also, we have this most favorite feature in SQL Server called SQL Server Integration Services. And it's in public preview today, as of today, in Azure as a PaaS service. So all your DTS package, now you can actually go deploy it from your SSMS to SQL Database as a service, to DBaaS. So you don't need to go fix your DTS package anymore. You can just deploy it, continue to run it. I know every company has lots of them because each department wants something, and everybody have a copy of data to move around. So seamless, we have active geo replicas, up to 4 replicas. It's a pattern like a data CDN, right? You have your CDNs, right? If you have web application worldwide somewhere, you have the CDN network deliver content, right? Without the data, those content are static. You keep up refreshing those content, you can't keep up, costs a lot of bandwidth, right? But if you can replicate data over there, your content is live. You can get the feedbacks. We have a Stack Overflow. That's what they use in AG to actually replicate data to their forums. Forums remote far reach, like Australia, replicate from US. This way, they can get a feedback discussion going in real time because there's database behind it. And the data sync, I have slides on it. Then I want to introduce managed instance. And this is actually the demo that Scott session as well this morning to actually make your SQL Server like a managed service in Azure. And with actually along with introducing this new SKUs, new offerings, and we introduce new business model, make it easier so you can bring the lessons and to Azure PaaS service so you don't have to pay the same SQL IP license twice, right? And we introduced the new database migration service. So with a few clicks, we can actually move your database to Azure PaaS service. Because with managed instance, we support lots of operations SQL Server has, including backup restore, add the BRK file, restore to PaaS service, and log replay like log shipping. So think about geo-replica, the readable secondary when it's active, and you can do lots of things with it, right? Even it's the same database, but now you can actually replicate to remote edge of your web service deployment and keep your web content active and interactive. And so you can have 4 replicas and can fit your topology, right? Because one database can serve many websites. So you just need to replicate to major hubs. You don't need to replicate everywhere, right? It gets expensive. And Azure Data Sync. This is actually based on Sync framework. We had this in a special application deployment mode for quite a while. Now we fully integrated this with Azure SQL Database. It supports all SQL servers, SQL Server VMs, and Azure SQL Database. And you can sync data using sync service. It's hub and spoke topology. And we have a session later, I think it's Wednesday, talking about how data sync works. We did lots of work on the performance. I know it could still be faster. And we changed the portal and the API interface to make it easier for you to actually deploy and use data sync service. And for every deployment, it will create a sync application and will coordinate multiple databases to sync across the same hub. I don't have slides. We do support transaction replication from SQL Server to Azure SQL Database. So you can enable, it's a one-way transaction replication from SQL Server to SQL Database. With a managed instance, we support bidirectional SQL Server transactional replication as well, because there's SQL agent now. So lots of choices, and just want to let you know we did not forget about the distributed application and the data sync and the transaction replication. And we also released more options. So on the current DTO model, we have two major categories of offerings, the singleton SQL databases and elastic pools, right? And both of these, we added more options in terms of sizes. And so the database now across all offerings can go up to 1 terabyte. With elastic pools can go up to collectively 4 terabytes. And we introduced more of these standard tiers, like S4 to S12, basically give you more CPUs, but use a little bit slower storage. But for lots of applications, I think that's actually very suitable because the price is a lot more favorable compared to the premium databases. So the main topic for the seamless and compatible are this managed instance. It's currently still in a private preview. We're going to go to public preview towards end of the year. And basically for any SQL application, managed instance really is designed for SQL Server. It's designed for SQL Server, and SQL Server is a good destination to migrate your Oracle and Sybase database as well. So for all relational database, and we design for your application, if you can run on SQL, you should be able to run on Azure PaaS service. And without, you actually have to go change your application to some PaaS model, right? It should just work. So PaaS service, like in cloud, is a good concept. But I am pretty sure many of you probably tried, right? There are different APIs, the surface area, and this is Dreisen's diagram, the road to PaaS. It's windy and full of alerts and blocks and everything, right? And managed instance will actually move PaaS closer to your application environment and make it easy and low friction to move. And the elastic will save your cost. So with that, we actually added one more category of offerings in Azure SQL Database called managed instance, side by side with the singletons and elastic pools. And since this is for SQL Server, we try to create a new business model that's actually more compatible with the SQL Server, how you size SQL Server, right? Because you size workload by looking at the CPU and memory and the storage, and we try to actually model how we sell managed instance in similar ways, so you can easily budgeting your forecast on your cost, everything, right? So in terms of application surface area, we near 100% compatible. I say near 100% is we don't artificially actually block any features anymore, because you have the instance, you have the node to yourself. It's pretty isolated. So we actually open up all the surface area actually supportable. And the ones not supportable in PaaS right now are the features actually have dependency on NTFS, on NT operating system, because we don't have it in Azure. And for example, file stream and the file table is not supported because they need NTFS drivers. We are not surfacing NTFS in managed instance. But everything else, like a SQL agent and a CLR, all these are supported. And also transactional replication. And since it's running on same fabric, same operating framework as Azure SQL Database, right? Service fabric, everything. So have all the same characteristics and capabilities of Azure SQL Database today. And we offer all the intelligence, performance tuning, and security features, and availability guarantees. That's all the same, the manageability, same as the SQL Azure as a PaaS service. And that's actually for your SQL Server now. And the business model, we price it very competitively. And so we looked at all the different offerings and the pricing across the different cloud vendor very closely. We believe we price it very competitively. And if it's not, I'm happy to have a discussion. And we make it transparent. And so you know you're paying for how many cores, and the storage size, and the IOs. And you know how much you're going to get used, right? And we make it painless, frictionless through database migration service, and support both the SQL migration, Oracle migration as well. So as I mentioned, security is important, isolation is important. By talking to many enterprise customers, right, the concept of running your large thousands of database estate in a shared environment is just uncomfortable. So the most popular ask generally we got is, can we have our own subnet? Can we have our own everything isolated that nobody else can access? And turn off that public access point from internet, right? So with the PaaS, that has been a little bit challenging, but with managed instance as a PaaS, we'll be able to provide a fully isolated deployment of a managed instance in your own subnet. And it's a native Azure VNet implementation, so support all the features Azure VNet provide. You can do network peering between the VNet where your instances are and to other VNet running the applications. And also, you can use the same subnet mask through express route to connect to your on-prem network. So you can literally just extend your subnet, but as long as you don't run out of IP address, right? And so this way, we actually give you a better way to run your enterprise data estate in the public cloud without having to pay the price of data centers, right? Maintaining data center. We'll patch everything for you, and we actually upgrade. You don't have to worry about all the headaches of the mundane headaches, right, to run your database. With that, I want to bring back Drazen to show you what managed instance look like.
Thank you, Lindsay. So before we go into the demo, I'm just going to walk you through shortly what I plan to do so that it's easier to track it when we start. Imagine you are having an application running on-premise, and basically you want to move the backend of the application to a PaaS service in Azure. PaaS is great. It will help you reduce some of the burden on the operational side. So definitely worth taking a look, and we recommend it as the first choice solution for database migrations. So let's imagine we have an application. I also have a small demo application that I'm going to use, and the steps that I'm going to go through, I'm going to take backups on my SQL Server 2012 instance that I have on the same machine where the demo app runs. I'm going to copy those backups, upload them to Azure Blob Storage to my account. Then I'm going to connect to my managed instance. I'm going to run a restore of those databases from Azure Blob Storage into the managed instance. And then I'm going to repoint the app. And the app should run just fine, as the same as it was before the migration. And then I'm going to look at the operational aspects a little bit in the end and show you the kind of compatibility that you can expect not only on the app side, but also on the operational side, for example, with maintenance jobs and similar things. Okay, so let's go into the demo. Just bring this down. And here I have a small demo app. It's a very simple app that I will now run. And as it starts running, it's actually running against a local SQL Server instance, which is on version SQL 2012, version 11. And it's running very simple reports, does some aggregations, and shows customers with top 10 transactions here. At the keynote, Scott Guthrie's keynote today, you were able to see a very realistic application that Lara Rubelki shown, the Stack Overflow. On my session for managed instance on Wednesday morning here at the Hyatt Regency Windermere, we're also going to show you a customer story from our private preview and also a realistic app being migrated. In this demo here, I'm using the backend that actually has 3 major databases, tenant data DB, shared master data DB, local master data DB. And these 3 databases, in step number 1, I need to do a backup locally onto my drives. I have already done this to speed this demo a little bit and not spend too much of Lindsay's time. And in fact, I have already went and using the Microsoft Azure Storage Explorer, I have also uploaded these backups to my blob storage account, to this folder DB backups, and there they go, local master data DB, shared master data DB, and tenant data DB are all uploaded there. They've been taken on a SQL Server 2012 instance. And now, if I go to my managed instance right here, I can create a credential that allows me to access a folder in my Azure Blob Storage account, and that's the folder in which backups are. So I'm just going to run this one here and refresh the credentials. And there I go. The credential has been created with the shared access key that I took from my Azure Blob Storage account. And then I can switch to the restore scripts, and basically for each one of my databases, I can do a restore. It's a regular restore database command that takes Azure Blob Storage URL instead of a local or a shared file system path. And I'm going to run this for a database. And of course, it starts the restore process. As it goes through, it will go through the necessary database upgrade steps from SQL Server 2012 onto the latest and greatest bits that SQL Database Managed Instance is running on. So SQL Database Managed Instance will run on the latest builds from SQL code that also run standalone databases in Azure. And with this, you will be able to take use of any new features that we develop in the cloud as soon as they get developed. With this, we are taking over the responsibility for upgrades. With this, we are taking responsibility for rolling out security patches. So those are some of the things that have been very, very painful today for you if you had sprawl of versions, instances, databases in your IT, and you had poor grasp on what you really have out there, and let alone patch it, upgrade it, and so on. So this is what Managed Instance will help you do once you migrate to the PaaS cloud. So I have finished this restore here, and actually I have previously restored the other 2 databases as well. So I have basically all 3 databases here. And now what I need to do is I will take this server name from here. This is my server name for managed instance. I will go to this app, stop it. I'll go to the settings here, change the connection string, and rerun the app. And there it goes. The app runs, and now it is connected to the SQL DB managed instance, right? So full compatibility, the app just kept running, nothing happened, right? Is that cool? Now, I'm sure all of you developers and people from app teams are now delighted app runs just fine, right? But what about the operational aspects? What about IT pros that may be managing this application on the back end? What are you going to do with your operational procedures that you already put together and been using for years, right? Well, that's where the last part of this demo comes. I will now switch back to the on-premise, to the SSMS connected to the on-premise instance. And I will take a look at my SQL agent jobs here, right? One of these jobs is a rebuild indexes job. Now that seems pretty useful, right? So it would be good to continue running that job in the cloud as well, right? Well, let's try do it. I will actually script this job out into a query window. I will do a select of all this text, switch to the SSMS that's connected to my managed instance, run a new query here, do a full copy, and press F5, right? And I'm done. I'm going to refresh the list of jobs, and here it is. It's the same job, rebuild indexes. It's the same code. I just scripted out on-premise. I just copied the code over, created. The same syntax is supported. So this will provide you a migration, very easy migration path for your SQL agent jobs, and they'll be running just fine, right? This unlocks a very large number of scenarios on the operational side in the cloud path. And I will go into more of these aspects at my session Wednesday morning. The demo will be significantly longer, so please come, and we can talk in more detail about managed instance. Lindsay, back to you. Thanks.
Yeah, so imagine all your SQL jobs would just work now, and because it was blocked, right? And now all your agent job works, you can actually use a use statement now. I know it's a small thing, but it's a big deal, right? For all your T-SQL writers, everybody use statement, right? You switch between databases. So all of this will just work. Oh, these capabilities enable these application migration seamless, right? Your application should just work. Your app developer didn't even know where they went, right? Update connection string. Well, make a connection string as service as your IT department, right? Change connection string and database goes different places. So in order to make all these even easier, not actually go write all scripts on everything, we actually have Azure Database Migration Service. You can do this through portal. You don't have to script everything out. I know DB likes scripts, right? But sometimes you don't have the scripts. You want somebody to just click through the UI, and all the service interfaces will automatically use all the infrastructure we built. Restore databases and playback logs to have minimum downtime for your application. So there's a session on database migration service, and this week as well, I think on Thursday. So it will support you migrate from Oracle and SQL to managed instance. For SQL, definitely minimum downtime. We're actually migrating the SharePoint Online right now. And for all the content databases, the maximum downtime is less than 5 minutes. We're moving all their content databases to managed service, past managed service. So move to the last part and talk about the business models. We have more offerings, have larger databases, and we're actually working on even larger databases. And hopefully next year when I'm here, I'm going to talk to you about how to run 100 terabytes database in a single database in the PaaS service. And we introduced separate compute and storage, so you can buy them separately, easier for you to cost. And we have Azure Hybrid Benefit. That's the one allow you to bring your on-prem license to Azure. So basically, you just pay the compute cost, and you can pay the license cost in bulk. The discount is very significant. So on the cost optimization, I want to just introduce a case study, right, we did with Microsoft IT. Microsoft is one of these top like 50 global 50 companies. We have a large IT department, and we have lots of developers like to write applications, and we have lots of SQL Server going around. So we looked at, it's about 40,000 databases, and I don't know how many servers, and what did we say, 15,000 SQL servers. this is after about 7-8 years of a consolidation effort. We tried schema consolidation, physical consolidation, instance consolidation. We still have this much databases and servers running around, right? So for past 3 years, and the initiative is a journey to the cloud. We want our IT running in the cloud. And of course, the easiest thing for them to do is we have this wonderful thing called ExpressRoute. And they're the first pilot, IT is the first pilot customer for ExpressRoute. And before you even code ExpressRoute, basically they connect the router, they bought a whole bunch of routers, and connect up to the cloud data center. In lots of cases, they're actually next to each other, right? So today, I think they have a couple of thousand routes going on still. When there's express routes, so then what happens? Azure Public Azure is basically extension your on-prem data center. We just deployed lots of VMs to it. And so now Microsoft.com extended to Azure. Then a couple of years passed, and year end, then we started looking at the cost. And even like the internal charge, these VMs cost a lot of money, right? Because there's nobody limiting the size and nobody limiting how many, and because the express routes connecting everybody, right? So then the big initiative is we need to cut cost. We need to go to PaaS and more manageable, more elastic, and cut cost. So we did use the part of a database migration service, scan all the databases. We find out there's 53% of the databases have service area actually compatible with Azure SQL Database today. Potentially, they could move, right? And move those databases can make it more elastic. And so the effort been going on to move these databases to Azure SQL Database. So then when you move, default is everybody pick the largest instance. That's kind of expensive as well, right? So then at the month end, year end, it goes, no, we cannot everybody use P15. That's too expensive, and don't really need P15. We want to actually see how many of these databases actually being used, and why is not automatic upsizing and downsizing, right? Or share the resource pool in Elastic Pool. So taking an example about 4,592 Azure databases actually being migrated already from on-prem to Azure, they're running. And we actually enable these automatic performance tuning features and automatic, actually, performance tier advisor. Right now, of course, it's in technical preview, it's internal only, but we're trying to try out, right? So with automatic index management and improved about the 1,000 queries just automatically. And then we actually overall in this about 4,500 databases use about 20 hours less of CPU every day. Because in cloud is elastic, right? You use less CPU means you pay less, right? And they reduce these logical reads. Logical reads need to, it's based on some sort of physical read. If it's not there, you actually have to do physical read to enable your logical reads, right? I/O costs money as well. So all of this, eventually, next slide, I will show you a translated cost savings. And the automatic plan correction capability is actually saved lots of trouble when you migrate from different version or migrate from on-prem to cloud. The plan changes sometimes, right? Can't really, these just mathematics based on estimations. And automatic plan regression saved lots of trouble with incidents. You know, you don't want to get code all the time in the night, right? It says, why is my query run slow without all the details? So this will save lots of trouble overall. And remember I was saying, put your database on autopilot, right? Everything done automatically for you. So now it comes to the cost saving part. Because with all the automatic tuning, we actually know the data access pattern. This is just an example because the portal actually is really, really deep, have lots of clicks in there through all these 5,000 databases. It's actually look at the query patterns, access patterns of all your database, the current performance tier. Each performance tier have their own different performance price point, right? We'll tell you either there's nobody using it, we recommend you to delete it. Actually, if you turn on to do this automatically, we're probably going to dormant that database for you, right? But to be safe, no. We just take recommendations and not doing automatically yet, right? And you can see Some of these will recommend upsize. Some of those will recommend just no change. And of course, lots of them recommend downsize because they're over-provisioned. And also, the size, sometimes it's because of CPU, sometimes it's because database size, right? And they have different recommendations. So the same thing, we take IT took the recommendation, shared it with their developers, and some of the group, actually developers, had accountability of cost. There's some developers doesn't. The one have accountability, they actually took the recommendation, downsized. So with the portion, actually a fairly small percentage being taken, right, doing the downsize, but even over 16 months, for just this less than 5,000 databases, they saved over $3 million on the cost. It's very significant. It shows up in your balance sheets. So the automatic autopilot performance optimization translated to automatic cost optimization is make a material difference to your bottom line. So that's the advantage of the PaaS service, database service, put your database on autopilot. So you can actually focus on your business, right? Not always spend the time justify the spreadsheets. You know, why is that number so high? So with that, we have 3 minutes left. So we're going to wrap up. In this session, we shared some of the new capabilities and our investment areas across 4 pillars. And the key takeaway, I was hoping you can walk away from this session, is running database in Azure PaaS SQL Database service is to put your database on autopilot. So you can focus your precious time on your business priorities instead of worrying about patching your servers and databases. Thank you.